Hello students, welcome back to the next module. In this module, we'll continue with MCQs on simple pendulum. So let's start with the first question. The bob of a simple pendulum is a hollow sphere with a small hole in the bottom. It is filled with sand and set into oscillation. Its periodic time t is measured at regular intervals. That means as it is set into vibration, we are measuring the time period at continuous regular intervals. As the sand starts coming out, we find that option A, t increases with time, option B, t does not change with time, option C, t first decreases and then increases, and option D, first increases and then decreases. Now students, we may think even if the sand comes out, we know mass is changing, but time period is independent of mass. Therefore, t does not change with time. That is option B should be the right answer. But no, students, that is not the right answer in this case. Since the question is not only on mass, in this MCQ we are involving the concept of again center of mass and the definition of length of simple pendulum. As we had in the last MCQ, the child standing on the swing question. Now let's understand this question. So we have a hollow sphere filled with sand. Now we know hollow sphere filled with sand will be just like a solid sphere and center of mass will be the geometric center. Now say L is the length of the system. Observe this diagram. As the sand starts coming out, center of mass of the system shifts downwards. So you can clearly see the new position of center of mass. Now, students, if the center of mass shifts downwards, we can say the effective length of the simple pendulum will also increase. Students, we should know here very clearly, length of a simple pendulum is the distance between the point of suspension and the center of mass of the system. So, if the center of mass shifts downwards, definitely the length will increase. And since we know t is directly proportional to root of L, if length increases, definitely the time period will also increase. Therefore, t initially or t first increases. Now, what happens when the sand completely comes out of the bob? Now let's check this diagram. So in this diagram we can very clearly see the sand is completely out. Now since completely out means the bob becomes completely hollow, and we know completely hollow bob center of mass is at the center. That means in this case now center of mass will shift upwards. So if the center of mass shifts upwards, the effective length will again decrease. Now if L decreases, then definitely student time period also decreases. So initially the length increases as the sand goes down, and therefore time period first increases. Then after the sand is completely out, the center of mass will again go up, the length will decrease and time period will decrease. So t first increases and then decreases. That is nothing but option D. So right answer for this MCQ is D. Let's move ahead, students. Let's see the next question. When the length of a simple pendulum is increased by 22 centimeters, the period increases by 20%. The original length of the simple pendulum is. Now, the length is increased by 22 centimeters. So, say the new length L2 is original, say L1 plus 22 centimeters. Next, we can see the time period increases by 20%. So, the new time period T2 will be original time period, that is T1 plus 20% of original, that is 20 by 100 of T1. This will become 120 upon 100 T1, which can be written as 1.2 T1. Now students, very clearly T is given and L is expected, so it is a problem of law of length, so T proportional to root L. Hence T2 upon T1 will be root of L2 upon L1. Let's substitute the respective value. So 1.2 upon T1 will be root of L1 plus 22 upon L1. Let's cancel T. The next step. Squaring on both sides we get 1.2 square is 1.44, and on the right hand side we get rid of the root sign on squaring and it becomes L1 plus 22 upon L1. Let's cross multiply L1, so this will become 1.44 L1 is equal to L1 plus 22. Let's take L1 on the other side and let us take it common as well. So it becomes L1 is 1.44 minus 1 is 22. So students, that becomes L1 into 0.44 is 22, and hence L1 will become 22 upon 0.44, or it is 2200 upon 44, that will become 100 upon 2, that is nothing but 50. So therefore original length is 50 centimeter, that is nothing but our option B. Therefore the right option is B. That's all in this model, students. See you in the next one.